Welcome. In this video, we will discuss quantum computing and its impact or potential impact on society. So I will say from the outset here that this is more of a introduction to the potential impacts of quantum computing on society rather than a technical introduction on how quantum computing works. That is quite a complicated topic, a pretty advanced topic. And if you are interested in that, I believe there are many nice resources on it on YouTube that you could explore further, or certainly many excellent classes at our universities that you could take on the subject. So this will be an introduction to more of the societal impact of these technologies. But let me start briefly by talking about what quantum computing is. And quantum computing is a field within computing that focuses on the utilization of principles of quantum mechanics to increase the speed and efficiency of computation. Uh, this means that quantum computing looks at means of computing at a level that is on the scale of thousands or beyond times quicker than a traditional computer, allowing it to solve complex problems that have baffled and prevented traditional computers from solving for decades in potentially matters of minutes. And the way that quantum computers make this happen is they operate on qubits rather than bits. And I have here a visualization of a classical bit that operates based on Boolean logic. Boolean logic being that there are two states that matter exist in, a zero or one. You could think of it as a light switch. So when a light switch is turned off, it would be in the state of zero. When it is turned on and light is coming through, it would be in the state of one. And we only have those two states of zero and one. When we work with computers, we are working with machines that have um, harnessed this ability to store information, send information, process information based on these principles of the zero and one, uh, scaled up to the scale of trillions. So we talk about things like gigabytes and megabytes and very large numbers of bytes. Well, a byte, it consists of 8 bits. And so when we're talking about uh, gigabytes of memory, when we're talking about gigabytes or of data that are being transferred, we're talking about very large scales of our bits here. Qubits work very differently, and so they work on the principles of quantum mechanics that suggest that states of matter actually can exist in more states than just zero or one. If you have the proper tools to measure it, they can exist potentially in the states of zero and one simultaneously. Or more correctly, they have the potentiality to exist in both the state of zero and one until they are measured. And this principle, while complex, essentially means that we can retain bits of information in these uncertain states for a period of time as they're transported. And this allows more information to be stored and computed in a much quicker time period. And this is not simply a hypothetical innovation. These are things that are already being developed. We have in the last couple of years here a product, Google's Willow chip. And you can see here from the advertising that it promotes being able to solve in 5 minutes a challenge or a problem that would take supercomputers 10 septillion years. And on the bottom right, we have IBM's quantum chip, which similarly boasts impressive capabilities. And one of the major benefits and challenges of quantum computing is that they can solve problems so quickly because with things like cybersecurity, we have traditionally operated with using a series of puzzles or algorithms um, that are very difficult for a traditional computer to hack because they involve solving a problem or guessing a combination that would take billions, trillions of years to actually guess correctly at random. Whereas with a quantum computer, it may take a matter of minutes because they can parse through a wide variety of possibilities or potentialities uh, basically at the same time and get to the answer that is needed. So, what are some of the areas of our society that are likely to be disrupted or impacted significantly by these innovations in quantum computing? Well, anything that involves solving problems, finding answers, connecting points A and B can potentially be disrupted by this technology. So when we think about artificial intelligence, the ability to take an input, analyze that input, and based on probabilities, present the result that we think will be most preferable to the user. Quantum computing technology will simply speed up that process, the speed at which a model can do all that computation and develop and produce that result. For the user, information retrieval, the ability to analyze everything there is in a database and based off a user's query, find the best or most relevant information and present that back to them. Very similar to with artificial intelligence, we're going to speed up that process, be able to look at the potentialities simultaneously and grab what is going to be most beneficial to the user. And robotics, the ability to understand the um, world around a computer and being able to perform certain actions or interact with other beings and objects in the environment. Again, the ability to learn and be able to navigate in that environment is going to be dramatically sped up with the use of these chips in the future. So, as I said, I am not an expert on the technical aspects of these technologies. I simply want it to be known from a societal impact standpoint that these are technologies that are rapidly developing and are worth discussing further, exploring further, and I hope you'll do that. So, if you are interested in more of the technical side of how these work, I suggest Grover's 1997 article. And this article discusses Grover's algorithm and the value of quantum mechanics for information retrieval. So, it's going to talk more about the foundations of quantum computing, the theory of quantum computing, and why it is so valuable for these tasks related to retrieving from large pools of information that might benefit innovations like our large language models and our information system and retrieval mechanisms. If you're more interested in what's going on right now with quantum computing, I recommend a 2024 article on the Google Willow chip that just talks about what is the Willow chip, what is coming out of the development of the Willow chip, and what its capabilities are. And both of these articles are linked in the description for you to enjoy. Thank you very much for watching this video, and I hope that I will see you in our next recording.